Section 5.5 is about solving rational equations and inequalities. So our goal for the day, that I feel like I'm just repeating myself, for solving rational equations and inequalities, really just focusing on the equations for now. Here's an example. We're asked to solve the equation x minus 18 over x equals 3. In general, one piece of advice that I have for these types of problems is get rid of the denominators as soon as possible. In order to do that, what I'm going to suggest we do is multiply everything by that denominator of x. So we're going to take x times x on this side, giving us x squared. We're going to take x times negative 18 over x and get just negative 18. And on the right side, we're just going to be left with 3x. So now we have something that looks a little more quadratic. What I'm going to suggest is subtract 3x from both sides. There we go. Minus 3x on both sides, and we end up with x squared minus 3x minus 18 equals 0. So now it's in a format that we can fairly nicely factor. So x squared minus 3x minus 18, breaking it up into that same grouping that we've done before, because they both have a leading because it has a leading coefficient of x1 x to the second. We're going to look at two terms that multiply to negative 18 and add to negative 3. That's negative 6 and positive 3, all that equal to 0. Now using the zero product property, either this is equal to 0 or this is equal to 0. So what makes x minus 6 equal to 0? Well, that's x equals 6. What makes x plus 3 equal to 0? That's x equals negative 3. So we have two solutions here that make this that make this equation true. We got x equals 6 and x equals negative 3. Quick reminder, if you ever want to check your work, go back and plug it back in. I'm just going to do it for one of these right quick. I'm going to check out x equals 6. I'm going to do 6 minus 18 over 6 equals 3. Well, that's 6 minus 18 over 6 is 3. So we got 6 minus 3 is 3. Well, that's true. Well, that was quick enough. Let's do the other one, 3. If we do 3 minus, scratch that, negative 3 minus 18 over negative 3. So we're just separating these, seeing if that's equal to 3. We got negative 3. Negative 18 over 3, that's positive 6. And negative 3 plus 6 does, in fact, equal 3. So that's just one way to nicely check your work. All right, let's try another one. We have 6 over x plus 5 over 4 equals negative 7 over 4. Two different ways we can approach this. I'm going to start by getting rid of the denominators. So I'm going to multiply everything to start by 4 on both sides. So when we distribute that to the 6 over x, that gives us 24 over x. When we distribute it to the 5 over 4, that just gives us 5. On the right side, negative 7 fourths multiplied by 4, we're just going to get negative 7. From here, we can just subtract 5 from both sides, and we end up with 24 over x equals negative 12. Now to solve for x, we got to get it out of the denominator, so let's multiply both sides by x. So on the the left side, the x's cancel out, we're left with just 24. On the right side, negative 12 times x is just negative 12x. To finish solving for x, we're going to go through at both sides and divide by negative 12. And we end up with negative 2 equals x. Now, something else you might have noticed you could have done at the beginning. I'm going to redo this problem, just in a slightly different approach. So we had 6 over x plus 5 over 4 equals negative 7 over 4. You may have noticed the 5 over 4 and the negative 7 over 4 had a common denominator. So I'm going to subtract 5 fourths from both sides. And we got 6 over x, and then negative 7 fourths minus 5 fourths is negative 12 over 4. Now, a couple different things you can do. You can reduce negative 12 over 4 if you want. Or if your instinct is to go ahead and cross multiply, you absolutely can. So you got 6 times 4 is 24. X times negative 12 is negative 12x. Hey, look, same thing we ended up with last time. We got divided by negative 12, divided by negative 12. We end up with negative 2 being equal to x. Again, we could have also reduced the negative 12 over 4. That's just the third way. There's a lot of different ways to do these problems. So just make sure you're taking it slowly. This example here, 5x over x minus 2 equals 3x plus 4 over x minus 2. Again, let's get rid of the denominator. Let's multiply both sides by x minus 2. Now, they conveniently have the same denominator on both sides, so the denominators cancel out. So effectively, it's as if we were just dealing with the equation 5x equals 3x plus 4. To start solving for x, I'm going to subtract 3x from both sides, and we got 2x equals 4. To To finish solving for x, we're going to divide by 2 on both sides, and we end up with x equals 2. But there's a problem. The problem comes from the original denominators. If you're to go back and plug in x equals 2 into those denominators, you're going to end up with, well, let's just check it out. If we do 5 times 2 over 2 minus 2 equals 3 times 2 plus 4 over 2 minus 2, we end up with 10 over 0. That's a problem. On the right side, you also end up with 10 over 0. So, I mean, at least you get the same thing on both sides, but it's still undefined. You can't really say 10 over 0 is 10 over 0, because that's like saying Glippenspiel is the same as Glorpenspiel. It's like I just made up two words that are undefined. You can't prove that they're equal to each other. That was like the worst example I could have ever come up with, but it is what it is. So we're going to talk about this. We did look at this in the past on a previous section of notes. Let's take a look at what that is. We're going to call that an extraneous solution. An extraneous solution is a solution that's found that's not a solution of your original equations. So we solve the rational equations, that sometimes they produce this. Always check your solutions by substituting them back in. The biggest thing we got to look for is that denominator. Is our solution something that would make one of our denominators equal to 0? So x equals 2 is an extraneous solution. So it's one of those annoying things in math where even if you do everything right, you get an answer that's still wrong. And I completely understand why that'd be frustrating. Let's take a look at another example. So we've got, we're asked to solve 2x minus 5 over x minus 8 plus x over 2 equals 11 over x minus 8. My advice, again, let's get rid of our denominators. So I'm going to start by multiplying this whole left side and right side by 2. So that way, when we distribute it to the 2x minus 5 over x minus 8, we get 4x minus 10 over x minus 8. When we distribute the 2 to x over 2, we're just left with x. On the right side, we're going to distribute the 2, and we're going to get 22 over x minus 8. Now, just like we did in the previous one, we're still trying to get rid of our denominators, so I'm going to multiply everything here by that denominator that we have left, the x minus 8. Now, the right side cleans up really nicely. We're just left with 22. On the left side, we're going to do x minus 8 times that first fraction. Well, that's nicely going to cancel out the denominator. We're going to get just 4x minus 10. But then we're also going to distribute the x minus 8 to the x. Well, which means we should probably distribute the x and the 8 to the x. So x minus 8 times x, that's going to give us plus x squared minus 8x. We should probably clean that up a little bit. So putting this in standard form, we got x squared, and then we have 4x minus 8x gives us a grand total of, negative 4x, and then we also have that minus 10, all that equal to 22. So it's starting to look a little more quadratic. To get everything on the same side, let's subtract 22. So that way we're going to get something that is hopefully nicely factorable. So negative 10 minus 22 is negative 32. We can factor out x squared minus 4x minus 32 to be x minus 8 times x plus 4 equals 0. From here, using the zero product property, we get two solutions. We get x equals 8 and x equals negative 4. But wait, we probably should address this right when we first do it. In fact, I sometimes do this intentionally, but now I'm like, oh, crud, I wish I'd paid attention. Looking at our original denominators, x minus 8, if we plug in 8, we get 0 in our denominator. We can't have that. So we're going to say x equals 8 is an extraneous solution, but x equals negative 4 is a normal solution. I'll just say is a solution. So this one only has one true solution, and x equals 8 is an extraneous solution.